Hi, everyone. Thank you so much for showing up for your learning. I know you're eager to review your grade 10 content so that we can smash the first unit of our course. And one of the main topics that we looked at in grade 10 were quadratics and the many different forms that quadratics can be expressed in algebraically and their different properties when we look at them visually on a graph or analyze them with a table of values. So our main form, the standard form, is y equals ax squared plus bx plus c. There's a video about it here, which will teach you about the role of a, b, and c in deciding the shape of that quadratic. Essentially, a, you'll notice, is changing the direction of opening of that parabola and also its stretch factor. How pulled is it away from its vertex? The c is influencing the y-intercept. As I change c, the y-intercept of that parabola changes. Doesn't matter its stretch factor, the y-intercept will stay the same. And b, many of my students don't know the role of b in changing the shape of a quadratic. Notice that I've also graphed the line y equals bx plus c. This is an mx plus b line. B is the slope of the line, this black line here. Notice that it's parallel, it's tangent to the parabola as it crosses the y-axis. As I change b, right now b is -1, and both the parabola and the line have a negative slope as they cross the y-axis. As I change this, the slope of the parabola changes. There's the slope of the parabola is 0 at the y-axis. It's flat right there. And then as b is bigger, it gets more and more slopey as it crosses the y-axis. So knowing this about a, b, and c tells you how to visualize that parabola instantly. And you know what to expect if you graph it in Desmos. And you can start to imagine it on the xy plane in your mind, which is an xy plane I want you to get very familiar with using and seeing that on your mental screen. Okay, but there's also a factored form and vertex form, and we want to be able to change between factored form and standard form and vertex form of a parabola with ease to get different information about a parabola. The roots of a parabola are where it crosses the x-axis, the points at which the parabola has a y value of 0, and those are often very significant points for different quadratic situations. And we get that in the factored form y equals a x minus r times x minus s. Let's take a look at how we convert from factored form to standard form. So here we've been asked to rewrite this quadratic in standard form. We could take a look at a visualization of this quadratic by inputting it into Desmos. So here's our parabola in standard in Desmos. It has a stretch factor of -4, so it's very stretched. It's opening downwards, and it has roots at -6 and +1. Notice that the signs of the roots are sign flippers. This is -6 and +1. So when I visualize this, I'm imagining I'm going to get a b value that is negative, because I can already see it has a negative slope as it crosses the y-axis, and it's crossing here at 24. So that actually tells me the c value. It's gonna come out to 24. So let's take a look at how we work with that algebraically, and it will match our visualization. So first of all, we can recopy the quadratic here. Okay. All right. Y equals -4, x plus 6, x minus 1. To expand one of these, we use we have to make sure that we multiply the first term by all of the terms in the bracket, and the second term by all of the terms in the second bracket. There's 2 terms here, 2 terms there, so that gives us 4 multiplications. You can use the FOIL acronym to keep that in mind. X times x here will be x squared. X times -1 will be minus x. 6 times x will be plus 6x. And 6 times -1 is -6. There we go. Now, carrying on, we're now going to collect like terms inside that bracket. Notice things that I'm not ready to process yet, I just bring them down along with me. I could have multiplied that in first, but I don't have to. You can do it in whatever order you like. X squared minus x. I can't subtract a centimeter from a number of square centimeters. In the same way, I can't subtract a square x from an x. They are not like terms anymore. So I have here x squared, it's the only x squared term, minus 5x, because I had 6 apples and you took away one, so I now have plus 5x, not minus 5x, minus 6. And now, this minus 4 here, it can get distributed in as well. Multiplying every term inside that bracket will be the last step of this problem. So I will be left with minus 4x squared minus 20x. Remember, we predicted a negative value of b. We thought that it was going to be a negative slope as it crossed the y-axis based on what Desmos was showing us. And negative 20 is just that. It's a very steep negative slope right there. Plus 24. Negative 4 times negative 6 is positive 24. And so that will be the answer that gets us all the donuts here. Minus 4x squared minus 20x plus 24. Then we click submit answer. We say, yes, I'm confident in that. And when you see that green check mark, you can either mentally or physically give yourself a pat on the back. It's a very important part of your math learning process, is a little reward built into every correct answer that you get. Any questions that you have, hit me up by email or come find me.